Hello student, I am Dr.A.K. Now I am going to discuss sp2 hybridization in C2H6 molecule, that is the ethane. Last class I have discussed hybridization in methane and H2O, NH3, like these molecules I have discussed. Means sp, sp2, sp3 hybridization I have discussed. Today I am going to discuss hybridization in C2H6 and C2H4. Example of in this example C2H6, here you will see that two carbon will be involved, CH3, CH3. Now I am going to discuss about the formation of C2H6, means sp3 hybridization. sp3 hybridization in C2H6 molecules. In ethane molecule, both the carbon atoms assume sp3 hybridization state. One of the four sp3 hybrid orbitals of carbon atom overlap axis-wise with the similar orbitals of other atom to form sp3 sigma bond, while the other three hybrid orbitals of each carbon atom are used in forming sp3s sigma bonds with hydrogen atoms. Like that way, sp3s, sp3s, sp3s means three hydrogen bond with one carbon, and same things with other carbon, sp3s, sp3s, sp3s. sp3 belong to carbon and s orbital belong to hydrogen. Then like that way in ethane bond is formed. Okay, here in ethane all bonds are sigma bond. This is the important things here, that in ethane carbon they will overlap, means sp3 sigma bond they will make, and with three orbitals, three hydrogen will overlap and make the bond, that is the sp3s bond, 3 sp3s bond. And with other carbon same things, sp3s sigma bond will be formed, means total in ethane 3 plus 3 plus 1, 7 sigma bond will be there. Okay, therefore in ethane CC bond length is, now bond length I am talking about, that in ethane carbon bond length is 154 picometer, and each carbon hydrogen bond length is 109 picometer. Why 109? In CH it is less and carbon is more, 154. Then here you can understand in C and H, here carbon and hydrogen bond length is less because this bond is strong. That carbon nucleus and hydrogen nucleus, then in this carbon is more electronegative than hydrogen. Hydrogen is electropositive. That's why here that this electron will come closer to, you can say, carbon. Hydrogen electron will come closer to carbon. That's why bond length will be less. But in carbon-carbon both have almost same, and attraction will be not like a CH bond, and their bond length is more. And bond angle, bond length I told you, and here carbon-carbon bond simply it is 180. Okay, I told about the these things. sp3 hybridization in C2H6 molecules means ethane molecules. Now I am going to discuss sp2 hybridization in C2H4 means ethylene, double bond. Here just listen, in the formation of ethene means double bond ethene molecule, one of the sp2 hybrid orbitals of carbon atom overlap axially with sp2 hybridized orbital of another carbon atom to form carbon-carbon sigma bond. This is the ordinary sigma bond. Now here double bond is there, then one bond is sigma bond, while the other two out of three, one orbital used up of both carbon. Now two are remaining, while the other two sp2 hybrid orbitals of each carbon atom are used for making sp2s sigma bond with the two hydrogen atoms. The now important things I am going to tell you means sp2 and s hydrogen bond also formed. Two sp2 orbitals was remaining with both carbon. Then both carbon made sp2s, sp2s, 2 bond with hydrogen. Okay, first carbon also and second carbon also. Now important things I am telling you. The unhybridized orbital of 2px or 2py, anything you can tell, any one is unhybridized orbital. Correct? Now role of unhybridized orbital I am telling you. The unhybridized orbital may be 2px or 2py. Any one are unhybridized. The unhybridized orbital of one carbon atom overlaps sidewise with the similar orbital of the other carbon atom to form big pi bond. Already I told many times that due to the sidewise overlapping, pi bond is formed. Sidewise or lateral overlapping, pi bond is formed. Then here pi bond is forming due to lateral overlapping or sidewise overlapping of unhybridized orbital, which consists of two equal electron clouds distributed above and below the plane of carbon. Actually, in unhybridized orbital, what happens? This unhybridized orbital consists of two equal electron cloud distributed above and below the plane of carbon and hydrogen atoms. Okay. Thus in ethane molecule, the carbon-carbon bond consists of one sp2 sigma bond and one pi bond. between p orbitals which are not used in the hybridization and are perpendicular to the plane of molecule. The bond length is 134 picometer. The CH bond is sp2s sigma, sp2s sigma with bond length 108 picometer. sp2s sigma bond means with hydrogen 108 picometer. The CH, the HCH bond angle means HCH means H carbon and hydrogen. HCH bond angle is 117.6 degree, while the HCC angle is CCC bond is there, na, carbon carbon, and H, then HCC angle is 121 degree. HCC bond is with carbon carbon hydrogen is attached, then with that angle is 121 degree. The formation of sigma and pi bond in ethane, you can I will send the these things diagram, you can see and quickly you can understand. Already I have sent in last two classes, I have sent. Again I will send, you can understand. Okay, this I have told about the carbon carbon. You can say in ethene double bond is there, then one bond is sigma bond and other bond is pi bond. Now I am going to discuss triple bond, means in acetylene, ethyne, Ethyne, in ethine there is a sp hybridization. sp hybridization in C2H2, ethine is C2H2, that is also called, example is acetylene. In the formation of ethine molecule, both the carbon atoms undergo sp hybridization. sp hybridization having two unhybridized orbital, that is the 2py and 2pz. Means two unhybridized orbital will be unhybridized. Okay, that having two unhybridized orbital, they have not taken part in hybridization. Unhybridized orbital 2px, 2py, in out of three, two have not taken in both carbon. Here again two carbon will come, then each carbon two orbitals are unhybridized, that is the py, 2py and 2pz in both carbon. Now they have a main role. Now just to listen, one sp hybrid orbitals of one carbon atom overlap axially with sp hybrid orbital of the other carbon atom to form carbon-carbon sigma bond, while the other hybridized orbital of each carbon atom overlap axially with the half-filled s orbital of hydrogen atom, forming sigma bonds. Means like in methane, ethane and ethylene, this also will make, you can say, with hydrogen they will make sigma bond. And now role of this, you can say, two unhybridized orbital. Now their role you can understand. Okay, each of the two unhybridized p orbitals of both carbon atoms overlap sidewise to form 2 pi bonds between the carbon atoms. This is important. Making bond with hydrogen, each carbon will make a bond with hydrogen. That is okay. That is like the other two, methane and ethene. You have seen here also one bond is they will make with one bond one carbon, other bond with other carbon, two hydrogen bond. But now you have seen that carbon they have made sigma bond, one sigma bond between carbon, other sigma bond with hydrogen. And both carbon makes one sigma bond with hydrogen. Then total 3 sigma bond. Now this unhybridized orbital, 2 unhybridized orbital on each carbon. These 2 unhybridized p orbitals of both the carbon atoms overlap sidewise to form what? To form 2 p orbitals, 2 pi bonds they will make. These 2 p orbitals they will overlap and they will make 2 pi bonds between the carbon atoms. So the triple bond between the 2 carbon atoms is made up of 1 sigma bond and 2 pi bonds. Okay, in diagram you can understand very clearly. Now I am going to discuss hybridization of elements involving d orbitals. Now role of d orbital is coming in hybridization. Just understand the elements present in the third period contain d orbitals in addition to s and p orbitals. The energy of the 3d orbitals are comparable to the energy of 3s and 3p. Comparable means not too much difference. Not too much difference. That's why actually the energy of 3d orbitals are comparable to the energy of 3s and 3p, and also the energy of 3 orbitals are also comparable to those of 4s and 4p. Listen carefully. 3d is comparable with both sides, means 3s, 3p, left side and right side, 4s and 4p. Means it is not 3d orbitals are not, you can say these things more, not too much difference, Okay, as a consequence, the hybridization involving either 3s, 3p and 3d hybridization can take place. Hybridization involving either 3s, 3p and 3d or 3d, 4s and 4p. Correct? In these two type of hybridization will take place. 3s, 3p, 3d. Correct? One type of hybridization. Other will be 3d, 4s and 4p. Hence, these two type of hybridization is possible with D. Then, since the difference in energy of 3p and 4s orbital is significant, since the difference in energies of 3p and 4s orbital is significant, no hybridization involving 3p, 3d and 4s orbital is possible, because 4s has more energy. Okay, that's why it is not possible. But with 3d it is possible. Okay, 3p, 3s, 3p, 3d is possible. And again, I told you 3d, 4s and 4p is possible because they are little closer. The important hybridization scheme, just I will tell you, the important hybridization scheme involving S, P and D orbitals that I am summarizing. What type of bond will be, means hybridization will take place, that I am telling you. See, shape of molecule or ion. Shape of molecule or ion means when you understand what will be the shape due to the hybridization. Okay, and what are the atomic orbitals involved, that also I will tell. And also I will tell examples. When DsP2 hybridization will take place, 1d, 1s and 2p atomic orbitals are involving. 1d, 1s and 2p atomic orbitals. Then hybridization is called DsP2. And shape of molecules or ions, whatever be, that will be a square planar. Question is asked in examination. Okay, hence keep in mind. And examples are nickel tetracyanide, NiCN4. Okay, 2 minus. Oxidation state of nickel is 2. Okay. Now second I am talking about that second hybridization, sp3d means 1s, 3p, 1d orbitals will take part. And that time molecule, what will be the shape of molecules? Then trigonal bipyramidal. And example is phosphorus pentafluoride, PF5 or PCl5. Phosphorus pentafluoride. This I have told you that this thing sp3d. Now another hybridization you see, sp3d2. sp3d2 means 1s, 3p and 2d. 1s, 3p and 2d. sp3d2. And its shape will be a square pyramidal. And example is BrF5. Bromine pentafluoride, interhalogen. That is called interhalogen molecule. And one more hybridization I am telling you, that is the sp3d2. sp3d2 reverse. What I told earlier, sp3d2. Here also sp3d2 is there. Here also 1s3p2d or d2sp3. d2 first to write d2sp3 means same things, only that it is coming early. D is coming early. Then here d2sp3 means 2d, 1s, 3p. And shape will be octahedral. Example is SF6. sulfur hexafluoride, or chromium CrF6 3 minus. CrF6 ion in the form of ion, CrF6 3 minus. Okay, this here chromium has +3 oxidation state. Or D2sp3, its example is cobalt cobalt hexaamine CONH3 whole 6 CONH3 whole 6 3 plus that is oxidation state of cobalt is 3 plus. Okay, that I have told you about the different type of hybridization involving d orbitals. Okay, and examples also I have given you, and shape also I have told you. Now just I will give example of PCl3 sp3d example I am giving you. The ground state and the excited state of outer electronic configuration of phosphorus, that is 15. You can write that the outermost orbital of phosphorus in ground state have 5 electron. Then in 3s 2 electron will be there, and in 3p single electron will be there. 3d will be vacant, means 5 vacant orbital will be there. 3d 5 vacant, and when it will be excited, then what will happen, that in 3s 2 electrons were there, that will jump to 1 electron will jump to 3d. Then now what will happen, in 3s 1 electron will remain, and 3p already one electron was there. Now 1 electron from the s went to 3d. Then now 5 orbitals are there, and each 5 1 electrons are there, and they hybridized, and after that 5 hybrid orbitals are there. Then next step, what will be the next step, that now 5 chlorine atom will come, and each chlorine atom will make bond with 5 p orbitals. 5 means this hybrid orbitals sp3d. Total 5 orbitals are there of equivalent energy. Then these 5 orbitals will make 5 bond with 5 chlorine atom, and PCl 5 will be formed. This I have told you. Now the 5 already I have told that how bond is formed. Now next this example you can see how this bond is formed. Now example I am giving you sp3d2 hybridization, sp3d2. Then now you know that in sulfur 6 electrons are there in outermost. Then in ground state 6 how will remain, then 3s 2 electron, and 3p 4 electron, means first 1 they will fill, and again it will paired up, 1 electron will come in the px, means 3s 2 electron and 3px 2 electron, and rest to 1 electron, that is a total 6 electron. And 3d is vacant, no electron. Okay, in ground state. Now see, after excitation, means after getting energy, what will happen, that 2 things will happen. Actually in ground state 3s and 3p, 3s has 2 electron and px have 2 electron, only p by pz 1 electron. Then now what will happen, that 1 electron from 3s and 3px both will jump in excitation state. Both will jump and will go to the d orbital. Both will go to the d orbital. 1 electron both will go to the dxy dyz 2 orbitals, 1 electron. Then now total orbitals become how much? 3, 1 plus 3 plus 2, total 6. Now in 3s only one electron will remain after jumping, and again in 3px 2 electron was there. Now only one electron will remain, because this electron from 3px also went to the d orbital, one d orbital opened, and from 3s also one electron went from the d, then another orbital opened. Then total now it became 3s means one orbital, and 3px py pz now 1 1 1 only, and 2 electron went, then 2 orbital, they went in the 2 orbital of 3d, out of 5 1 1 they went. Then now orbitals having single electron became 6, 1 3s, 3 3p, and 2 d. Okay, then 1 plus 3 plus 2, total 6. Then this 6 will hybridized, and these 6 hybrid orbitals, now they will make bond. They will make bond with 6 fluorine. 6 fluorine they will overlap, and they will make the bond, and molecule will exist, and SF6 molecules will exist, and hybridization will be called sp3d2 hybridization. And now I have finished hybridization completely. Okay, and now I am stopping only here. Next class I will start molecular orbital 3 MOT. Thank you.